Lovely Monday. I'm sure you are all fired up for this 2-hour session that we are going to have. It's a very nice session. It deals with our paper 2, the topic analytical geometry. I want to tell you, if you are not aware, that this topic actually counts around 15 marks or in your paper 2. Just to get us warmed up, before that, I'm sure you can just have your pens and pen and paper ready. And you look at this exercise here. The question may be saying, solve for x. Can we spend 2-3 minutes on that exercise? X to the power 2 minus x is less than 6. Can you answer that question? It should only take us 2 to 3 minutes. And this is one question that normally count 4 marks in our final examination. It's an inequality. Please check with the person next to you. I realize that you have started scribbling down. X to the power 2 minus x is less than 0. It's less than 6 actually. I'm sure we agree that the very first thing is to have the additive inverse of 6, which is a negative 6, and the first step then becomes that is less than 0. It is in our standard position. It's a very important step to have in our quadratic equation. It's normally given a mark. It's a very important step. The second thing, check with the person next to you. If we have the factors correct, we need to factorize at the second step now. And for this one, you agree with me, I'm sure that the factors of x squared will be x multiplied by x. They give you x squared. And the factors of 6, we have the 3 multiplied by 2. We also have 6 multiplied by 1. But between these factors, we take those factors that when we subtract will give us the middle term. Between these two pairs of factors, we take any factors that when we subtract will give us a negative 1. And I'm sure you agree with me that we'll have negative 3 plus 2, and the bigger factor must take the sign of the middle term. We have the critical values here. Sometimes you call them the zeros. It will be a negative 2 and a 3. Because when you substitute a 3 here for x, you have 3 minus 3, it's a 0. When you substitute a negative 2 here for x, it's a negative 2 plus 2, it also gives you a 0. Then we have this tool to get the solution set. This is what your teachers have been drilling you about. It is always plus, minus, plus. Here at negative 2, we agreed it is a 0 here for negative 2. Here for 3, it is also a 0 here for 3. 3 minus 3 give you a 0 as well. Now this is not necessarily the answer, but just a tool that we use for us to work out the solution set. And because here our inequality is less than 0, it means we check between a positive, a negative, and a positive, which one is less than 0. And we all agree that a negative is the one which is less than 0, meaning our solution set becomes negative 2 is less than x, but x is less than 3. That becomes the solution set. Sometimes in other cases we can also use a graph as a tool, not necessarily the answer, but as a tool for us to can work out the solution set. And we have seen that our quadratic equation, the coefficient of x squared is positive, so our parabola graph is facing up. And we agree even here that the area which is less than 0 for this graph, this part is the one which is negative for y-axis, meaning less than 0, negative, and this becomes the area which is less than 0. Hence our solution set, of course, will still be this one, that between -2 and a 3, this is the area which is less than 0, as our inequality indicated to us. Good. I'm sure everyone is fine, is excited. It's a very nice one. Please work on them again continuously. These kind of exercises are very nice exercises, showcase exercises for our paper 1 examination. Those 20 marks in paper 1, very important. Good. We'll now continue with our business for today. Like I said, that we are going to work on analytical geometry, and analytical geometry is a topic on paper 2. I want you and your friend next to you to just take out your copies of the information sheet. Your copies of the information sheet. The information sheet is what we use to actually assist us with appropriate formulae that are needed for appropriate questions as we answer our paper. And on the information sheet, when you talk of analytical geometry, the expression for the distance, becomes a very important expression that we must be familiar with. And the expression for the distance, like I said, distance between any 2 points, particularly for a non-vertical straight line. And here we now have the expression for the coordinates of the midpoint. The coordinate, because the coordinates of the midpoint at the end, it must be x and y, the coordinates of the midpoint. So if you see any question that talks of the coordinates of the midpoint, this becomes a very important expression to can think of. It becomes for us to can use it. And we all agree that here you see now it is the equation of a straight line. The equation of the straight line, and this m, we know m always stands for the gradient on the straight line. M stands for the gradient on the straight line, and this also becomes the equation of the straight line. But you need to note that if this one is the gradient, which is m, for this to be used, you must have the gradient, you must also have 1 point. When you have the gradient and a point, then you can be able to use that expression there in a case where the question says determine the equation of the straight line given for the exercise. And of course, this is how we calculate our gradient. Any question about the gradient, this is the expression for the gradient, change in y over change in x. It means you must have 2 points for you to calculate the gradient of a straight line. In this case, the first point is y1, the second point is y2. The first point is x1, the second point we have x2 there. The first point, the value of x there, you call it x1, and on the second point, the value of x there becomes x2. Now this is the expression for the angle of inclination. The angle of inclination. The angle of inclination, we use this expression here for us to find the angle of inclination. M meaning the gradient is equated to tangent theta. Theta can be any angle that we are looking for in the form of angle of inclination. Tomorrow then we will talk about this, which is the equation of a circle with any center as the point A and B, and R we know that is the radius. Fine, but today we are mainly going to work on exercises about the distance between 2 points, the coordinates of the midpoint, the equation of a straight line, the the equation of the straight line where you have the gradient and a point, and this is our gradient expression formula, and this is the angle. So we have this formula on the formula sheet. So make sure that anytime you sit for an examination or assessment, you have your formula sheet and you know where are you going to get the formula for the equation on analytical geometry. Look at this nice exercise here. I want us to look at this exercise as our first exercise for the day. In this exercise, it's written there, question 1, analytical geometry. In this exercise, we realize that we are given 2 points. P is the point 2 and -3, and Q is the point 1 and -1 are points in a Cartesian plane. These are points in a Cartesian plane. It means if you have a Cartesian plane like this, I want us to draw this Cartesian plane. If we have a Cartesian plane like this, you have those 2 points on a Cartesian plane. We are aware that on a Cartesian plane, this becomes our y-axis, and that becomes x-axis. Now the first point there says 2 for x, and -3 for y. 2 and -3, and the other point says 1 for x and -1 for y. 1 for x and -1 for y. These are our 2 points. It's P here, and the other point is Q now. Now when you look at these 2 points, we can join them, and once we join them, we see now we have a straight line there. The first point is 1, in fact it's 2 for x, and -3. The other point is 1 and -1. Now look at the first point. The first question now says, calculate the distance between P and Q. What is the distance between P and Q? Calculate the distance. And we have just said, once you talk of the distance between any 2 points, we go to our formula sheet. So in our examination room, once the question says the distance, look at the formula sheet, make sure that you have the right expression for the distance between any 2 points. Can you and your friend next to you on your exercise or a clean page just note down that expression for the distance between 2 points? The square root of x2 minus x1 all squared plus y2 minus y1 all squared. That will give us the distance between 2 points. I'll give you 1 or so minute, 2 minutes, just to work the answer for the first question, which says the distance between P and Q. Write down the answer between your friends and between you and your friend, the distance between 2 points. Good. I'm sure everybody's done now. I like it when you say this is peanuts. I'm sure a matric learner by this time then you should be saying this is peanuts. So make sure that you have everything right. These are the marks we cannot afford to lose. It's good. Let's just check if everybody is happy with the answer you've got. The distance between 2 points, that's our formula there. So we substitute in, we can call PQ. So we can say this is x1, this is y1, this is x2, and that is y2. So we just substitute in the values. We said x2 is 1 minus, and then x1 is 2 all to the power 2 plus y2 is -1. I want you to look at the substitution here. y2 is -1 minus, and y1 here is negative 3. Look at the way I write it. It's negative 3. This must be all to the power 2. And you simplify it further. Here you have negative 1 squared, 1 minus 2 plus, you simplify further here, negative 1, negative, it makes plus 3 here, all to the power 2. And then you continue, you have the square root of negative 1 squared. I'm sure we understand that negative 1 squared is negative 1 multiplied by negative 1 to the power 2, only 2 of the negative 1 multiplied, and this gives us a positive, a plus. Here negative 1 plus 3 is a 2, and 2 to the power 2 is 4, and then we have our answer here as the square root of 5. I'm sure we all agree about the answer, that for that one, the answer there becomes the distance between 2 points. The answer becomes the square root of 5. I know at this time most of us can only do it with a calculator. It is fully accepted. Just show your formula, that you have the formula, your substitution, because marks are allocated for those, are very important. Then you can then simplify to have the square root of 5. Good. And the next question says determine the coordinates of M, and M is the midpoint of PQ. The midpoint. So the midpoint M, it means it's a point that lies somewhere in the middle of P and Q. The midpoint is a point that lies there in the middle between P and Q. If this was our 1.1, now our 1.2. And we have talked about the midpoint. Remember, from your formula sheet, just to make correct formula here, this expression here is the expression for the midpoint. So you don't have to struggle. Just go to the formula sheet and you remember that M, the big M, is the midpoint. Now this question says, I'll give you 2 minutes just to work out the midpoint quickly. Right. I'm sure we are done, everybody. Now we still have our point PQ. Remember, we marked them here earlier on. We marked them that the other one is x1, y1, and the other one will be x2. We still use those points as PQ, the midpoint. Now we just make a substitution here. X1, we have seen x1 is 2. In fact, x1 is 2 and x2 is 1, plus 1 over 2. And y1 is negative 3 plus, and y2 there is negative 1. We just do the correct substitution there. And when you simplify here, you have 3 over 2. I'm sure we agree about that one. 3 over 2. And this one, negative 3 multiplied by negative is negative 1. Then you have negative 3 minus 1, negative 4 divided by 2. You have it as negative 2. Good. I'm sure we agree about that. They become now the coordinates of the midpoint. And you can see that we use the formula sheet. We use the formula sheet to check our formula for the midpoint. And once we have it, we correctly placed it here. We made it a substitution. We took care of this negative to put it inside the brackets. We simplified it, and then we have the answer. Good. We are doing very, very well now. And then we can continue to the next question. There it says, question 1.3 here. It says, determine the gradient. Determine the gradient of that line. Remember, the gradient is of a straight line PQ. Determine the gradient. Look at the formula sheet. Remember the formula sheet? We said that's what guides us. It have all the formulas we need for this section here. M, it's a small m now. It's a small m, and you can see in all these straight lines, M, gradient, M, gradient, M. This is what you use to calculate the gradient M. And the big M is what? The coordinates of the midpoint. Now we are here with the gradient, the small m. The The question says determine the gradient of PQ. Because PQ is our straight line, non-vertical straight line, then we can calculate the gradient. Okay, I'll give you 2 minutes to just quickly work out the gradient. Good. I'm sure everybody's fine with that one. The gradient, we still remember have marked. We did a very correct thing. You know, when we earlier started by marking our points PQ, that this one is x1, y1, this one is x2, y2. It is the second point, x and y. The second x, the second y. You get what I mean? So don't hesitate on your question paper. On this section, if they talk of PQ or any other 2 points, don't hesitate, mark them with a pencil on the paper. It makes things much easier for you. So you just substitute here. I'm sure that's what you have done. You just substitute in here. Your y2, we can easily see y2 is y minus 1. y2 is -1 and our y1 is -3. I want you to realize how we handle these negative values. x2 is 1 minus x1 is also 2. There you go. Look at these values. y2 -1 minus, the formula says there is a minus there, and then for y1, look at y1. y1, we put -3 in brackets because y1 itself is -3. So we put it in brackets so that we can simplify. So you have -1, negative multiplied by negative. We all know that is +3. There you go. 1 minus 2, we write it, it's -1. Then you can simplify there. -1 plus 3 is 2 over -1. I'm sure our gradient becomes a -2. We all agree that our gradient is a negative. You are doing very well. Check with your friend there. I'm sure you have the gradient as, and we are happy with the gradient as a -2 because we can see our straight line is in the second and the third quadrant, so the gradient must be negative. We are happy about that gradient. It must be a negative gradient because it's in the second and the third quadrant. For a straight line, that straight line, the gradient must be negative. And on that note, let us just remind you that once your line is in the first and the second quadrant of your Cartesian plane, then you expect your gradient to be a positive gradient. So in this case, because our line is in this manner, we are happy about it. This way we are happy about it because it's a negative gradient, and our answer that we get here is a -2, meaning it must be a correct gradient for that line. Good, we are doing very well. I like the way you guys enjoy using the formula sheet, because the formula sheet guides us in everything we do, and I cannot overemphasize the substitution. Once you have the formula there, make sure that you do the correct substitution there. The next question, I like it as well. Now it says determine, it says here, determine the equation of a line passing through PQ. Remember our point PQ. Now the question says find the equation of that line. Look at our line. Here the point is PQ. They say there's a line that passes through these 2 points. Let's draw that line. There is a straight line passing through those points. You see the line there. Now the question says, what is the equation of that line? What is the equation of the line passing through those 2 points? We are going back. Here is our question there. We are again going back to what? We are again determine 1.4, determine the equation of a line passing there. We are again now going to go back to our formula sheet. We are now at 1.4, and the question now says here, look at the question now, the formula sheet. The formula sheet says the equation, this is what we can use for the equation. And we said, if you are looking for equation, find the gradient. If you have the gradient of the line, look for any point. Once you have the gradient and a point, then you can find the equation. And fortunate for us, already we have the gradient here. I'm writing the expression y minus y1, the gradient x minus x1. I'll first give you 2 minutes to work on that equation. You already realize that above there we have calculated the gradient already of the line passing through PQ. We now just need to calculate the equation. Good. You guys are doing very, very well now. I'm sure really you are looking forward to have this kind of a question in your examination. It is going to be there. And you realize the importance of us knowing our formula in the formula sheet. So we have the gradient. We write there the y minus y1. And our gradient, we have it above there. It makes things much easier for us. There we are. So we need a point, because the formula here says have the gradient and a point. And fortunate for us, on this line passing through PQ, we have 2 points. So we can take any of the 2 points. And fortunately, we already have this point. We called it x1, y1. Why don't we use it? We can already use it. We can use it, and we say y minus, and our y1 we said is -3, so we write there -3 x minus our x1 we said is 2, so we write 2 for x1. So we made the correct substitution here. First we substitute our gradient, which we already have above there, and then we took any of the points between P and Q. But now already we have marked P to be our x1, y1, so we can use the same point. Or you can take another point, Q for instance, as long as you have a point on that line. The gradient of the line, number one, very important, and a point on that line. Then you are fine. Then we simplify here. As you have done very nicely there. I can see your work. You did very well. -2 multiplied by that. We cannot afford to make any mistakes here, because we already have everything correct, so that we get maximum point. The additive inverse of 3 there, -3, so we have the plus 1, because it's 4 minus 3 there, it becomes then plus 1. So this becomes our equation. You really should be proud of yourselves, because we have these exercises very well, especially the way you use your formula sheet. It makes things very, very easy for you. Good. We are doing very well. Good. Now determine the angle of inclination of PQ. Remember now PQ are 2 points, but those 2 points are actually on a line. So once we have a line there, we can talk of the angle of inclination. Determine the angle of inclination. That is the question we have now here. Determine the angle of inclination of PQ. And for the angle of inclination, the formula sheet, I really want us to be aware how important the formula sheet helps us now here. Remember we said now the gradient equals to tangent theta, give us the angle of inclination. Determine the angle of inclination there. Good. Now it means you have tangent theta. It comes from the formula sheet. Tangent theta is equals to m. This is the formula that comes from the formula sheet. We just use it now to find the angle of inclination. Here is the formula from the formula sheet, angle of inclination. Good. Here we write down tangent theta is equals to m. Then you can take your calculator. I'll give you 2 minutes just to work out the angle of inclination, and we know this m, small letters m, is the gradient, and you look up there, already you have calculated the gradient, so it means you don't have to calculate it from the beginning again. I'll give you 2 minutes to finish off the angle of inclination there. Good. So we have the tangent theta is equated to -2 because we had it up there that the gradient is -2. Good. So there we go. Tangent theta is equals to -2. That is very, very good. Now on your calculators there, now you go second function, shift the tangent of -2 because you want the angle. The tangent there of our gradient, -2, because you are looking for the angle. Where is it now? We have shift tangent, and then we have -2. There we go. On our calculators is equals to, once it is a -63, then we write theta is equals to 180 degrees minus 63,439,4882 degrees. Our angle 116,57 degrees, corrected to 2 decimal places. So our angle of inclination therefore becomes 116,57 degrees, and this angle of inclination, remember, it must always be a positive angle because our angle is a positive angle. It goes in an anti-clockwise direction. Here it is, and we are happy it is an obtuse angle. The angle we found here, it's an obtuse angle of 116,57 degrees. It's an obtuse angle, so it must be the correct angle of inclination. How steep is the line? This straight line is what the angle of inclination assists us with. Good. I want to really clap hands for you. You did very, very well on this exercise, and you used here your formula sheet very, very nicely. And you can see that for those 15 marks in your question paper in November, for those 15 marks, everything relies really on this formula, the formula that you find on the formula sheet. Everything, so we cannot afford to miss that 15 marks. Please understand that by the end of this session, we are going to have a break. We'll have extra we are having extra 2 exercises to work on after break, but you realize that for most of all these questions here, that 15 marks, we must be fully comfortable with it. We have used the formula sheet to work on all the exercises there, and I like these formulas because they are all grouped next to each other. This is where our 15 to 20 marks or so is lying here on this formula sheet. Having talked of the gradient and the other concept from that question, we did very well for that first exercise. I'm sure it's necessary that we also mention or remind ourselves that when you talk of the gradient of a line, which we have seen that it's a small m, the gradient of a line, for any on a Cartesian plane, or let me just draw a Cartesian plane here. for any two parallel lines, I'm just drawing parallel lines here. For any two parallel lines, these are lines which are parallel. Once you say those two lines are parallel, let us not forget therefore that the gradient of this line, which we can call M1, how does it relate to the gradient of the other line? That is very, very important. We need to keep it in mind that once the lines are parallel lines, the gradient of the first line will be the same as the gradient of the second line. For parallel lines, that's what we have learned about. I'm sure our teachers have shown us that. We had exercises about that. For any parallel lines, if you have 2 points on this line and you calculate the gradient there, whatever gradient we get for M1 for the first line, then you must know that that gradient will be the same as the gradient of the other line. And there is another relationship again if your lines are perpendicular to each other. If your lines are perpendicular to each other. We said here these are parallel lines. For parallel lines, the gradient of the first line is surely the same value or the same gradient of as the second line. If we say the gradient of this first line, because you see the gradients here will be positive gradients. If you say the gradient is 2, then automatically the gradient of the second line also will be 2. Now there's also a relationship between the lines that we normally call perpendicular lines. I'll draw it just here. Perpendicular lines. Perpendicular lines. When you have two lines which we say they are perpendicular, and normally that is the other property for perpendicular. Perpendicular lines. When we say lines are perpendicular to each other, meaning that here at the point of contact they have a 90-degree angle. Here they have a 90-degree angle at the point of cut. When we say the lines are perpendicular, then we know that the gradient of this line, which we may call M1, and the gradient of the other line, which we can call M2, the product of the two gradients, when you multiply the two gradients, they must always be equal to -1. When you multiply the two gradients, these two gradients must always give you a -1. Now, we know with these perpendicular lines, we have two things that we need to keep in mind. Very important things is that we can only say that our lines are perpendicular only if this gradient multiplied this gradient give us -1. Then we can conclude and say these two lines are perpendicular lines. That is one condition. But the other very important condition that you need to take note of is the angle formed at a point of contact. Where these two angles meet, where these two angles meet, once this angle is 90 degrees, then we can again conclude that the two lines are perpendicular. So what do you expect about perpendicular? Anything perpendicular, you have a 90-degree angle in mind at the point of contact. You also have what? The product of the two gradients. If they give you -1, then you know that the two lines are perpendicular. Good. Note those two important things about the gradient. We have learned about the gradient and the angle of inclination. How do we use the gradient to calculate the angle of inclination? So at least now I've mentioned three things about the gradient. One, gradient being used for the angle of inclination because it's the gradient of a line, remember. and the angle of inclination is actually on the line as well. Now number 2, we have talked about the gradient. In as far as parallel lines are concerned, the gradient, the two gradients will be equal to each other when the lines are parallel. And also we have mentioned that the product of the two gradients would give you a -1. Then we know that the lines are perpendicular. The angle formed at a point of contact for the two lines then also becomes a 90-degree angle, a right angle, 90-degree angle. Because this question, we'll see with the exercises that we are going to do, sometimes we get given any figure. For an example, a figure like this one, we can all see that it's a triangle. A figure like this one with 3 points, let's call them point A, B, C. Now for us in this case, in this triangle, to can show that this triangle is a right angled triangle. It's a right angled triangle. Right angled triangle, it means this angle is 90 degrees. For us, we can show that, I'm just mentioning it just before you go to break. We need to remember that once we can have the gradient here and the gradient of this line, the gradient of that line, when we multiply the two gradients, once they give us -1, then we know that this line is perpendicular to this other line, meaning that the angle here is 90-degree angle. Therefore, the triangle must be a right-angled triangle. We are going to take